Hi guys, my name is Peter C. Dogwa Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's video, I will be discussing finding derivatives of functions, and I'll be looking at some little bit of complicated functions and using the product, the power rule to find those derivatives. So we're going to use the differentiation formulas and not the first principle of derivative. So it's a kind of continuation of problems we've been solving from the previous videos up to present. So in the previous video, we did some problems up to 4 problems. So this is the 5th problem, and in this problem, we're asked to find each derivative using the power rule. So the first problem says we must find the derivative of y equals to the square root of x plus the cube root of x plus the square root of x raised to the 7th power. So the first thing you need to do if you see a problem in this form, in a radical form, you first need to put it within the general form of the power rule. So the power rule general form is some x raised to a power, right? So that power can be a whole number, a fractional number, a negative number, and just whatever number, but it should just be a variable raised to a power. So we can do the same for this. We can rewrite this expression, y equals. Now, square root means that expression under raised to some 1 over 2. So this expression, which we call the radicand, x is raised to the power 1 over 2. Because within this indexed right here, we have 2. This is 2. And the power of this radicand is 1. So it's 1 divided by 2. So move to the second one. You have plus. Now the power here is 1. So it's x raised to the power 1 divided by 3. Plus. Now the power here is 7 and here is 2. So it's x raised to the power 7 over 2. Now we notice that each term now is in this form x raised to the power n. So in the first term, we have n to be half. The second term, we have n to be 1/3 and just like that. So we have y prime now to be the derivative of each of these terms. So the derivative of the first one, remember the rule says that we must bring the power down, which is n. We bring n down, 1 over 2. We rewrite the base or the variable, and we subtract 1 from the power. So we have differentiated this first term. Plus, we move to the next term. We have 1 over 3 x raised to the power 1 over 3 minus 1. Plus, again, we bring this power down, 7 over 2 x raised to the power 7 over 2 minus 1. So we have differentiated every term. It's just for us to simplify. So we have 1 over 2 x raised to the power. Now, 1 over 2 minus 1. So we can apply some shortcut method by saying 2 times 1 is minus 2. Then we attach this positive 1 to it and divide it by the denominator of the first fraction. So now we have 1 minus 2 to just be minus 1 over 2. The next one we have 1 over 3 x raised to the power 1 over 3 minus 1. So 1 over 3 minus 1 is the same thing that we did. So it's 1 over 3. So you just say 3 times 1 is 3. Then divided by the denominator 3. So it's just 1 minus 3 to be minus 2 over 3. Then plus 7 over 2 x raised to the power. So 2 times 1 is minus 2 plus 7 over 2. So it's like 5 over 2. So if we further simplify it, all those terms with negative, they go within the denominator, and the ones with positive just remain. So we have, in this first area, we have 1 over 2x raised to the power half, 1 over 2, plus 1 over 3x raised to the power positive 3 over 2, plus 7 over 2 x raised to the power 5 over 2. So we have found the derivative of this first one. We'll move to the second problem. So again, we first need to put this problem in this form, x raised to some n. So because it is not in that form, we have to rewrite it. So we have f of x is equal x now divided by the first term, that's the denominator, the root of x. And we know that the root of x is just x raised to the power 1 over 2, right? Plus 1 all over the same root of x, which is now 1 over 2. Because when the denominators are the same, you can take one of them and add the numerators. That's exactly. So this is just the expansion of this one. So the next thing we want to do is to make each term to just be a variable raised to the power. So we can apply some rules here, division of leg terms or leg bases. So if you have x raised to the power 1 and you have x raised to the power 1 over 2, we can, the rules of exponent says we subtract the power of the denominator. So it's x raised to a divided by x raised to b is just equals to x raised to the power a minus b. So the power of the denominator must be taken from the numerator. So it's just 1 minus 1 over 2 plus x raised to the power. Now we send this 1 over 2 in the numerator, it becomes negative 1 over 2. So we have not started differentiating, we're just trying to simplify the problem so that it appears in that form. So now we have x raised to the power now is 1 minus half. So you know that 1 banana minus half banana is just equal to half, because half plus half gives you 1. Or you can say 2 times 1 is 2, positive 2 minus 1. So it's just equal to 1 over 2. Now the next one you have plus x raised to the power minus 1 over 2. Now we can find the derivative. So we say f prime of x is now equal, we bring the power down 1 over 2, x raised to the power 1 over 2, and we subtract 1 from the power. Plus, we bring this power down again, minus 1 over 2. We rewrite the base, and we subtract 1 from the power. So we can further simplify. You have f prime of x to be 1 over 2, x raised to the power now 2 times 1 is 2, minus 2 now, plus this 1. So we just give us minus 1 over 2. Minus 1 over 2, x raised to the power 2 times 1 is 2. So 2 is negative, then 1 is negative, so the signs are the same. So it's just minus 3 over 2. So we can ensure that all of the powers with negative go within the denominator. So we bring the power down. First, we can say 2 and 2. Now this is half, so we can factor out half 1 over 2. So we just left with 1 all over x raised to the power 1 over 2 minus 1 all over x raised to the power 3 over 2. Now this 3 over 2 can be rewritten as x times 1, x times x raised to the power 1 over 2. That is 3 over 2. So if this is x times x raised to the power 1 over 2, and we want to factor out a kind of common term, a common factor. So you see here you have x to the power half and x to the power half. So we can factor it out. You have f prime of x now to just be equal to 1 over 2. So this x to the power half coming outside as x to the power 1 over 2. Then what is left there now is this whole thing now is just 1 minus. So this is rewritten in this form. So this is already out. So you just left with x. So it's 1 over x. So if we left, we can, further simplify that expression in the parentheses. So we can have this to be 1, or we just say x times 1 is x. So it's x minus 1, all over x. So this x now can be attached to this expression, which is 2 times x to the power 1 over 2. So x to the power 1 over 2 times x. So you see that the bases are the same, you just add the power, so it's half plus 1. So now this will give you x minus 1 raised to the power 2 times x raised to the power. So it's just like saying 2 times 1, right? It's 2 plus this 1 is now 3 over 2. So this is our derivative. So we do the last problem. The last problem said y equals to x to the power 5 over 2 plus 3x plus 4. So y prime now, because each term is in that form, y prime will just be 5 over 2 x raised to the power, we subtract 1 from it. So it's 5 over 2 minus 1 plus 3x. The power is 1. You can say 3 times 1 is 3. And then x raised to the power 1 minus 1. The derivative of a constant goes to 0. So y prime now will just give us 5 over 2 x raised to the power. Now 2 times 1 is 2. So 2 is negative. If you take negative 2 from in 5, you're left with 3. Now over this same 2 plus 3. So this is your answer. So these are the ways in which we can find derivative of functions of these forms using the power rule. So thanks ever so much for watching. See you in our next video.